Hi guys, hope you're all enjoying your lockdown experiences. What I've been doing for various reasons is just working on my programming, just updating my skills. So I'm still working on my little simulator for viruses or virus propagation. It's based on one side scene, it's not completely original. The programming's completely original. But I just tried to recreate something I saw on a newspaper website. So I'm just adding to it. What I haven't added yet is a user interface, so I'm still having to use the Unity editor, to edit all the parameters. So you've got all the variables down here. I gave them a bit of a tidy up today, so they're in different sections, different categories. So let's just set up a scenario. Blah blah blah. That to 1,000. Right. So we've got. Let's see. No self-isolation. The virus lasts for 14 days once you've got it, and percentage. I see. Yeah. So that's in the wrong category really, because that's not a report statistic. But so the percent infected is 20% at the moment. But I'll show you quickly. This is the actual code, and this is something I did today. For example, I went over this bit and added these little headers, but these are all the parameters that control the simulation. So let's just set it running. So this is what the government don't want us doing. So let's start it running and see what it does. I'll run it in the editor rather than as a standalone bit of software. But here we go. So the green ones are the guys who don't have it. The red ones are the infected ones. The blue ones are the ones that have an immunity because they've had it and they've recovered. So you can see from the graph here, it marks off every 10 days in grey there, and this is quite a steep curve. So it tells you here high infected, 63% of the people got infected, and there's still some people infected. The simulation's still running, and it's killed off 5.3% of the population. I've exaggerated that aspect of the simulation because you need meaningful numbers. You can get it so the infection rate takes you down to about 1 or 2%, which seems a bit more realistic if we did that. And also something else I need to add to the simulation is when this hits a peak here, which as I say got to 6.3%, we need some sort of tolerance, so saying like the health service will crash once it hits say 35% or something like that, and then increase the number of deaths. Obviously with no functioning health service, because there'd be people on long-term cancer treatment who couldn't be treated, or people who were in a car accident who couldn't be treated anymore and things like that. You can see a little thing that I've added now is they've all got a little like a strategy game, they've got a little health bar over the top of them. So let's take that off, and that's simulating 300 blobs as they're called. We've got 300 little people going around. So let's have a go with self-isolation. We'll add 70% self-isolation, and so let me see, that got up to 65% total, and we killed off, I can't remember what percentage of the population, but let's see. So this is 70% self-isolating. There we go. So you can see it simulates self-isolating by just simply not moving them around. They can still become infected and they can still infect because they'd have people delivering things, and also it simulates the effect of them carefully going out shopping and everything. But now you can see the graph is nowhere near as tall, so that's what you call flattening the curve that everyone's going on about, and it gets up to a high of 26.3%. So presumably the health service can still cope. And also you can see there's a lot of green. It does actually calculate the statistics, but it doesn't display it yet. But a lot of people have never had the virus, so we're getting some herd immunity as well. I think it's just one guy infected now, 0.3% of the 300, and so that ends the simulation. So that's what we're left with. It got up to 26%. The curve was very much flattened, and so I should add as a disclaimer, I don't know that any of this works or is correct. I'm not an expert in epidemiology or viruses or anything like that. This is just using my own common sense to work it out, but that does seem to be similar to all the graphs that I'm seeing in newspapers, and so they must be running a model a bit like this one I created. But so this lasts 54 days. I forgot how much the other one lasted, but it sort of it prolongs the whole thing, and also it protects quite a lot of lives. Sometimes when you manipulate the variables, it doesn't actually protect that many lives, but it does at least lengthen things out. So obviously the health service can still function, but you can see there's loads of these green guys that've never had the virus. So one thing I'm going to add is what happens now if we start adding some more infected people, because there's always going to be a bit of it in society until there's a vaccination program, to see how well this group would survive if it was reintroduced. So let's say 5% of them had it now, but I haven't added that yet. I might make it so you just press the space bar and it adds 5% or something, or it's done on a schedule. But okay, so let's look at a bit of a nightmare scenario, because some people are saying this is possible, but this is going to be an exaggerated version. So we'll switch off self-isolating. You can see there's quite a lot of variables for how the self-isolating works. If there's a delay, I haven't tried that yet. I've just added the code for that today, this morning. But so this is sort of like the nightmare scenario where the immunity period isn't very long lasting. So the parameters are you're infectious for 14 days, you have it for 14 days, and the immunity only lasts for 14 days. So we'll see what that brings about. There we go. So this is just people going around doing anything they want, and you can see it does the same thing again, but already the percent infected and the number dead is going to beat that other simulation, because although you can see the blue bit there is the number that are immune now. That's going up and up like it did before, but after a while it'll start to decline because the infection is the immunity is short-lived. And as I say, this is a bit of an exaggerated thing, and also this is something that this simulation takes into account that I don't think most people are aware of. If it does come back at all, every time you get it you're going to be weakened. So this removes, I forget how many points. So in other words, someone might be able to survive having it once, but they maybe can't survive having it, say, 3 times. And every time they get it, their fitness is going to be reduced. So you can see what's happening here first of all is that it's coming back. You see people are getting it again. There's another wave of it, and then the immunity goes back up. But you can see every peak is lower. Now one of the reasons every peak is lower is because there's less people. But we've now lost 20% of the population. As I say, this is greatly exaggerated compared to what would really happen. Say if the immunity only lasts 3 months or something. But this is the kind of thing we'd be looking at. It would just hang around forever and it would just wear people down. You see the graph scales itself. That took an entire day to get that working properly. So I wanted to be adding to my simulation, but I was fiddling around with the graphics instead, which is a bit disappointing. But now we're up to 34% dead. The transmission rate is low, but it always hangs around. It always hangs around because this thing is so infectious. So it's just going to keep going and going. And nearly 40% dead. It's not really enough to slow the spread. And you can see that, I don't know if it'll come through on the encoding for the video, but you can see that the little health bars, they were great big green bars, and now they're going yellow and they're getting smaller because people are sort of, you know, their health's getting worn down from getting it over and over. I'm going to add something so it tells you how many times each of these, or what the average is for how many times each of them has had it. So there were some of them that were very fit at the beginning, but they've maybe had it 3 times now. So it's wearing them down and wearing them down. 52% dead now. And it's just the same pattern repeated. I'll just let it go to the end. And you can see those grey markers up here are every 10 days. And the simulation's now been going for 200 days. Get to the end. So you can see what the trend is. The deaths are going up. Okay, so that's just going to run and run until there's practically no population left. Yeah. Okay. But it just keeps coming back in waves. So this is something to watch out for if it's found that the immunity is short-lived. I mean, there is certainly some immunity, but it might be that it only lasts 3 months or it only lasts a year, and we have to start planning for that, because that'll be the danger, people having to survive it more than once. So we have to plan for that. But let's just see what the effect is of, because this is the nightmare scenario, but let's see what the effect is of. Now, I'm a big advocate of mask wearing, and I would like to see an argument against it. Now, in my model, I'll set it to 20% reduction in your probability of infecting someone else if you wear a mask outside the house, and 50% reduction in it coming back in. Now, I don't know if they're right. I don't think the experts know, and that goes for all of these variables. The experts just don't know what the variables are, because none of us do. But I think that's conservative, saying you're 20% less likely to get infected and you're 50% less likely to transmit it. So let's see if that can solve the problem. Mask wearing instead of lockdown. So you can see that the white ones are wearing a mask and the pink ones are wearing a mask and they're infected. So you can see it has a similar effect, that reduction, to this maybe seems terrible still, but it does flatten the curve, just like a lockdown does, just like a lockdown of 70% of the population. And I'll not run the simulation, but what happens is it just seems to sort of hang around. Immunity is never allowed to build up in this model, but it does create, it is an improved situation, so it'll never get above that initial peak. It never goes back up again in my models, but it gets to a high of 32% rather than it just sort of being like one tidal wave after another, overwhelming the health service. And also, in terms of policy, if there was a situation like this, they could maybe do something about it, you know, like tracking people down who've had the virus, tracking people who had contact with them, that sort of thing. But we're already up to 8.3%. But if nothing is done and it's left like this, basically what's going to happen is it will just wear the population down, and you'll never get a death rate that's high enough to stop transmission. There'll still be people coming into contact with each other. So let's try again with that nightmare scenario, masks, which, as I say, I'm an advocate of, and I think that will come off as a blunder on the part of the British government for saying we shouldn't wear masks, or that they don't do anything. I think they do something. I think they're well worth it. So let's try self-isolation. Let's try combining masks with self-isolation as well. See what that does. And as I say, I'm no expert in any of this. I don't know. I don't have expertise in virology or epidemiology or anything. It's just using my own common sense to design a model. As I was teaching myself a modern programming language, but you can see this kind of, it's always a problem, it's always lingering there. But those two measures together, people wearing masks every time they leave the house or every time they come into contact with someone from outside of their house, it does actually bring it back under control. So I think the government have been idiots, and they maybe realise they've made a mistake, and that's why they don't want to tell people. Now, if I'm wrong, I don't know, there could be some mechanism that I don't understand. So maybe if an ordinary person wears a mask, for example, maybe the virus cells, they build up behind the mask or something and multiply or something like that, and it's actually dangerous for some reason. I don't know, but I don't think so, and that's fairly conservative. 20% chance less of passing it on. And let's see, simulation has ended now on day 73, but that was using 70% lockdown, and or was it 70% wearing masks? So I think the masks are worth it, but I'll not go into much more detail. There's various things you can do. We can take the masks off. So 0% wearing masks now. The immunity period will push it back up to 1,000 days, so it's basically infinite immunity. I can't really simulate beyond that because I haven't added something that reintroduces the virus once everyone's no longer got it. I think I've got some real curiosity about some of that. I would like to know what happens, so I will add that. I have the code for social distancing, or I have some of it. Let's make 50% social distancing, but at the moment it just changes the graphics and it just gives them a wider circle, and also the graphics have gone out of date because they don't have a status bar above them. But this is one of the next things I'm going to work on, and then I will start adding the user interface so you don't have to run it in this programming environment. So there's going to be like slider bars, but obviously that doesn't work properly. They're actually more likely. I need to make it so that they stop in their tracks once they get close to someone, and then try and move in the opposite direction to social distance. Kind of like women do in a disco when I'm present. But right. But let's see. Let's switch social distancing off because it doesn't work yet. It just changes the graphics and changes the radius. You can actually watch now. I will try now. We'll switch off self-isolating. Oh no, we'll have self-isolating on for 70% of the population, but it doesn't come in for 10 days. But once it's in, it's permanently on. You can make it so, for example, I experimented a bit with phasing it in and out, so it maybe goes for 7 days. 7 days of lockdown and then 7 days of letting people out. And what seemed to happen, and again I don't know how accurate my simulation is, but let's just try this because I've just written the code for this today and I've not run it before, so I don't know what it will do. Let's see, so this is same parameters, same transmission rate and everything, but so it goes up. Then after 10 days, 70% of them will start to self-isolate. So it hits 60%, yeah, and then they permanently self-isolate. 61%, that's flattened out. And I suppose this is what the government are hoping. Now, one thing I hope they've taken into account is that, and it's heartless to talk about it in terms of pure statistics, but the first people to die are the most vulnerable people, and they've removed the most vulnerable people. So when the death rate goes down, it doesn't necessarily mean that the amount of the virus in the population is substantially decreased. So that does seem to, let me see, percentage dead, 73. It's nowhere near as good as if you start with self-isolation. But starting with self-isolation, it might seem impossible because we can't go back in time. But if this disease does come back in waves, that might be the key. Using IT, data and the internet and everything so GPs and ordinary people can just report the symptoms, and then a government administrator can order a lockout of, say, Birmingham or something like that. But that's not too bad. But I'll just show you quickly, I suppose as the final scenario, we'll just self-isolation delay. Let's have self-isolation length 7 days. It's going to do it 20 times. We'll say 200 times just so it does it forever. And self-isolation break is 7. So it'll be 7 days on, 7 days off. And then I suppose... Oh, anyway, so we'll try that. We'll see what happens. And what it seems to do when I've run it before, I've actually changed the size of the simulation now, so I don't know if it'll be different. But what it seems to do is it just seems to produce some of the benefits of... So it's kind of like a best of both worlds, or a worst of both worlds, if you like, because now we've got 7 days of it going up and up, but then it stops again. So it never gets quite as high. That gets to 49.7, so 50%, rather than up into the upper 60s like it did before. So then it starts going down when people self-isolate. So it does actually produce some of the benefits of permanent lockdown or long-term lockdown. But that's just in my simulation. I don't know how accurate that would be. It's going to die out now, I think, hopefully. He's hoping. Oh, so that works quite well. So it flattens the curve, but unfortunately it still hits 50%, so it's nowhere near as good as long-term social isolation. But obviously I don't have a graph for economic harm, and then the harm to the physical and mental health of the people who are self-isolating. Anyway, so that's what I've been working on. It's cheerful stuff. I've been working on the code. I've been tidying a lot of it up today, and like I say, I've still got loads of little scenarios I want to test out for my own curiosity. So if you can get a herd immunity, a sustainable herd immunity, and then start reintroducing the virus to see what happens, to see to see how sustainable it really is, to see if herd immunity could ever have worked, things like that. But and then I'm going to start creating a user interface, so you don't have to be a programmer to use this. You can there'll just be slider bars and things like that, so you'll set it up and then making it into a kind of a game where the scenarios that you've got to beat by putting points, putting budget into things like self-isolation. But that's what I've been working on, so I hope you're all doing well and you're all safe, and please bear in mind these scenarios are quite exaggerated and I have no idea if they're effective or not. So here we go, and